Hello everyone and welcome to another video. So today I want to talk a little bit about understanding and installing these guys. These are what are called a fuse tap, add a fuse. Sometimes they're also called things like a piggyback fuse holder. And what these do is these allow you a nice, clean, easy way to basically add a circuit to your car's electrical system if you want to power an accessory. So in my case, for example, I recently got this dash cam and it comes with a little wiring harness. So this is going to allow me to tap into my car's electrical and power this dash cam using the car's electrical system. So in order to do this, obviously you're going to need to be able to wire this into the car's electrical system, and that's where the fuse tap comes in handy because it allows you a nice clean way to get access to the car's electrical system while not influencing or modifying the existing electrical diagram. So the first thing that we should maybe talk about is, again, just understanding what this fuse tap is and how it works. So if you look at the geometry of this fuse tap, it's pretty darn interesting. It looks like it's got two spades or blades for a normal fuse, and then it has two spots for fuses on top of it, and then a kind of power takeout line. So the idea with this is that you will insert this fuse tap with these two blades into the car's a fuse box, into an active fuse socket. Then what you're going to do is you're going to take actually what you're first going to do is you're going to pull out the fuse from the car's electrical circuit, right, from the car's fuse box, so you have an open spot. You take this fuse out, you plug in the fuse tap, and then you take the original fuse that you pulled out and you put it down here into the bottom slot of the fuse tap, okay? So the idea is once you do that, you are now going to basically restore the original circuit. So everything's gonna operate like normal. Now, here's where the extra bit comes in. That's what this second slot on the top is. That is gonna allow you to take a second fuse. This is the fuse that's gonna be protecting or associated with your new accessory. That goes into the top slot, like that. So now you have the original fuse on the bottom, the new fuse on the top, and once you put the new fuse into the top, you then will have an electrical connection and power can be taken off from this kind of pigtail or this power takeoff line, okay? So that's the geometry of what this does. Let's talk about the actual circuit diagram of what is going on behind the scenes of this, because this actually is somewhat important, okay? So you can go ahead, grab yourself a multimeter if you want and prove to yourself that this is the connections. This is a pretty standard way this is done. So what happens is this is what the fuse tap circuit diagram looks like, this red and blue picture up top. So again, I'm going to orient this in the same direction so we can kind of see this, okay? So blade A and blade B, again, that's down here, blade A and blade B, those are going to go into the existing slot on your car's fuse box, okay? Then the original fuse I've drawn here in blue, that's this one on the bottom. And then there's a connection between blade A and one side of the original fuse and blade A and the other side and one side of the new fuse, okay? And then, as we saw, you go through the new fuse and that comes out to this piggyback, this pigtail line or this power takeoff line. And then the original fuse goes through to blade B, okay? So this is the circuit diagram, and now what we might want to talk about a little bit is the most common thing I think people get wrong with these fuse taps, or I don't know if I want to say get wrong, but maybe do it in a suboptimal fashion, is installing this in an orientation, because I know a lot of people think fuses don't have a polarity, and you're absolutely correct. The fuse itself doesn't have the polarity, but as you can see, this is not a symmetrical wiring diagram, as we're going to see in a second. So let's talk about this. Let's look at maybe the original, normal fuse system before we talk about any fuse taps. The way this is working, a fuse is a really, really simple system, right? The idea is, right, you got your 12-volt battery over here, right? This is your car battery, okay? You go up through this fuse. This is the original fuse of your car. Let's, for giggles, let's make up some number. Let's say that this is a 15 amp fuse, okay? So this is a 15 amp fuse, okay? So the 15 amp fuse is going to protect this circuit because you have some original load down here, right? Maybe it's like your heated seats or something like that. This is the electrical load. Let's say normally this consumes, I don't know, let's make up a number. Normally, let's say 11 amps, right? Okay, so everything is fine here, right? In this case, there's 11 amps normally flowing through this circuit. It's not anywhere near the 15 amps for the fuse. It's not going to blow the fuse. This is how it normally works, right? Okay, so the way the fuse tap works is we are going to literally take this fuse tap and bring it down, and we're going to connect it like such. We're going to take this fuse out and we're going to connect the blade A and blade B into that location. Okay, so that's kind of the picture that I've drawn over here. This is how this is done correctly. Okay, so what you're going to do is you're going to take blade A, right, which is the blade that is the farthest away from the pigtail. Okay, that's going to be connected to the battery, the side. Okay. So in this configuration, this is what ends up happening, right? You still have your original circuit here that is protected by the original 15 amp fuse, right? And you have the original load. And again, if everything's working normally, this load is still drawing 11 amps, right? And since this is a 15 amp fuse, we're okay. Right? And now what happens is when you have the fuse tap in this orientation, the fuse tap, what we're going to do is we're going to install this new fuse, which is then going to power your new accessory, which I've kind of drawn over here in red, right? So let's say that this new accessory draws, I don't know, let's make this up, 5 amps, okay? Okay? So maybe what you do is in this new fuse is you install a 10 amp fuse, right? Okay, so again, you can see in this picture that everything is fine in this diagram, right? Because if we were to go ahead and write KCL or Kirchhoff's current law at, for example, this point, right, coming off the battery, we see that 11 amps is coming down this circuit, 5 amps is coming down, so really over here we do have 16 amps flowing, but in this case, things are fine, right? Because you might have 16 amps here, but 11 amps are going to split off, go through your original circuit, 5 amps are going to split off going through your new circuit, and everything is going to be okay, all right, if you install it this way. So the thing that is key is we have to remember that blade A, it's going to have to be connected to the positive side of the battery, okay? Now, what people sometimes get wrong is they reverse the orientation of this fuse tap and they install it quote-unquote backwards, right? We're going to see here that in some cases it's going to work, some cases this might give you a problem, right? Let's see what happens if you install the fuse tap in the incorrect orientation, you know, quote unquote backwards, right? Then you get a circuit diagram that looks like this, okay? And again, what we see is that, okay, this normal circuit or the normal nominal load, the original load is still going to draw 11 amps, right? But now when you install it backwards, you actually are taking power off on the other side of the fuse, right? In other words, in order for this new accessory that I'm installing, if this thing still takes and draws 5 amps nominally, now we see that, okay, if I write KCL over here, right, on the other side of the fuse, that means we have 16 amps this way, and then 5 amps will come off to power your new, and then 11 amps will come down to power your original circuit, right? So in this case, now you have a slight problem because you now have exceeded the original 15 amp circuit here, and you're going to lose, actually, this fuse is going to blow, right? So this fuse, the original fuse is going to blow, which, you know, this new fuse is probably not going to blow. But you've killed the entire circuit, right? So now you're going to lose both your original circuit and the accessory circuit in this case. Now, if these don't draw that much, right? If we don't come close to the original circuit, you can get away with this orientation, right? Right? Because if your new accessory that you're installing is only, you know, 3 amps, okay, then you are now in a situation where we're okay because this drops down to 14 amps like that, right? Okay, which won't blow this, and you'll be okay. So long story short, it may or may not be feasible, but this is sort of the safer, more robust way to install it, okay? So again, I just wanted to point that out because I don't see a lot of discussion on the actual circuit diagram and actually writing KCL for these circuits to try to analyze what's going on. So this is why the orientation on this fuse tap does matter. So let's go for this orientation, and as we see, What this means is we actually do have to identify in the fuse box which side of the fuse is connected to the battery and which side of the fuse is connected to the load, okay? And it turns out that's actually not that hard. So let's go ahead and talk about that next. All right, so now that we understand the circuit diagram associated with both this fuse tap and the larger electrical system, we realize that on the larger electrical system when we go into the car, we're going to need to know which side of the fuse is hooked up directly to the positive terminal of the battery. So one way to do that is to go ahead and find yourself a fuse, okay? Now this fuse, as you can actually see, a lot of these fuses have tiny little, I don't know if you can see that. Let me see if I can get it to zoom in. Come on, zoom in on this. Okay, great. You can see it's got actually a little spot here at the top of the fuse where you can easily touch a probe from your multimeter. So you can use this. You can basically, this is an easy way to insert this into your fuse box, and then that gives you a convenient spot to touch to go ahead and determine if it's connected to which side or not. Now, the only issue right now is this is an intact fuse, right? So these two prongs they're electrically connected, right? In fact, if you want to prove that to yourself, just go ahead, set your multimeter to resistance. Let's go ahead and touch both of these prongs, and you see, yeah, 0 resistance, right? Because this fuse is intact. So what we want to do is, I actually want to blow this fuse, or I've actually seen some people cut this in half and just use this, because again, all we care about is we want this blade because it's an easy blade to insert into the larger fuse box and give us a convenient place to make a measurement. So you can either cut this fuse in half, or we can blow this fuse, meaning let's pass some electrical current through this above its rated limit of, I guess this is a 3 amp fuse, it's pretty small. So let's just do that. And the easy way we can do this is let's blow this fuse by, let me go ahead, grab a couple of electrical leads. Okay, let's get these alligator clips. I'll clip one end to one side of the fuse. I'll clip my black lead to the other side of the fuse. Okay, and then all we need to do is go ahead and let's just touch this to a battery, right? You've got a AA battery probably lying around the house. And as soon as we touch this to the fuse, we should just have electrical current coming from the battery. And since there's no resistance in this, I think the current through the circuit should be quite high. And in fact, I'm going to make sure my leads here say, yeah, look at this. This lead can take up to 10 amps. So I'm not worried about the electrical leads, but hopefully this 3 amp fuse should just blow and melt and we should be good to go. So let's go ahead and do that right now. Again, the orientation doesn't matter because I just want current flowing through this. So, zzz. Okay, there we go. So hopefully that has blown this fuse. And to check that, let's go ahead and move our test leads out of the way. Let's grab our multimeter back here. Okay, and go ahead and touch these prongs on either side of the fuse. And there you go. Now we get overload, right? Now there's infinite resistance because I've blown this fuse. So now these two prongs on the top are disconnected from one another. So again, if I tried to use these and touch like such, oh gosh, it's kind of hard to do without an assistant here. Let me see if I can do this. There we go. There we go, right? Overload. Great. So now this is a very good blown fuse that I can use. I can go ahead and insert it into the car fuse box, and then we can easily discern which side of the fuse is actually connected to the positive terminal of the car battery. So let's go ahead and bring this down, and we can use this to make that identification. All right, so now we're at the step of needing to crack open the fuse box and find a circuit that we can use to add that fuse tab to. So the first thing I want to do is I want to find a grounded location inside the fuse box. So what that means is, again, I need to find a location that is going to be connected back to the negative terminal or the ground of the battery. So what you can see what I've done here is I've just hooked up a lead here. I don't know, it's kind of hard, probably hard to see, but I've hooked up one end of my multimeter to the ground of the battery. So now let's just come back over here, and finally we'll come over to the interior fuse panel or the fuse box. So that on my car is right here. So let's just pop this thing open, and there we have it. Okay, so here's the interior fuse box, and all I need to do right now is I need to find, a lot of times parts of the chassis is connected and grounded back to the battery, but I just want to confirm that we have an electrical connection going back to the negative of the battery. So I'm going to take my multimeter, turn it on to resistance for ohms, and now the black end, as we just saw, is leading all the way back to the negative terminal of the battery. So what I'm going to do is I'm going to go around and tap on some of these things and see what of this is connected back to the battery. So obviously this plastic is not going to work, right? But for example, there might be like these little, there's like a little screw here, these pieces of metal. So if I touch the piece of the screw, how about, let's try that screw. Aha, look at that. The resistance goes to 0. So there we go. So this screw is grounded and is connected all the way back to the negative of the battery. So we're going to be able to use that for a grounding point for our eventual fuse tap installation. So that is a good grounding spot. You know, I think you can tap probably a couple of these other spots and they probably work. Yeah, see, that works. I don't know if there's any other screws. Oh, here's a screw up here. Yeah, great. So all of these are grounded to the negative. So I think we should be pretty good to go. Okay, now that we've got the ground set up, we can go ahead and try to figure out which of these circuits do we want to tap into. So you're going to want to obviously go to your car's manual and find out what the fuse setup is. So in this case, I've gone ahead and downloaded this. I've looked at it. I've tried to identify. We are going to want to only use circuits that are kind of non-critical. So I'm going to stay away from things like airbags, telematics control units, things like that that I really do not want to have any chance of messing up. And instead, I'm going to look at things like the washer and wiper pump, or like the heated steering wheel or the heated seats. Those circuits should probably be fine and I don't have to worry about them too much. So the thing to think about now is a lot of cars have two types of circuits. Some of these circuits are powered all the time. They're just directly connected to the battery, even if the car is off. So that might be nice if your accessory needs to run all the time. But of course, the downside of that is you're draining the battery all the time. The second type of circuit are some of these circuits that only become live when the car is turned on. So we're going to want to think about that as we're doing this diagnostic. So right now the car is off. So let's pull some of these non-critical fuses and see what they look like, and importantly, which side is connected to the battery and which side is connected to the load. So for example, let's take a look at number, how about number 8 here? So according to my diagram, that is a heated seat relay. So all I need to do is just go ahead, and it's this fuse down here. So I just grab a pair of pliers right here and pull this guy. Okay, great. So this is the good fuse. I pulled that. Now what I can do is let's go take our fuse that we blew, right? We just saw this. So this fuse is not connected, but what I can do is I can insert this. It's going to give me an easy spot to make a connection to. So if I push that in there, great. Now I can take my multimeter that we were just doing. So again, the black side is still connected to the negative side of the battery. So I'm going to now change this from resistance. Let's change it to DC voltage. So now I can measure DC voltage. Right now there's nothing, but now because this fuse is blown, I can now touch the metal tips or the heads of either side of the fuse, and I can try to determine which side is connected to the battery and which side is connected to the accessory. So for example, if I start on the right side and I poke in here, right there we go. Look at that, 0 volts. So I don't think this is connected to the battery. So let's click on the left side of the circuit like that. Aha, look at that, 12 volts. So in this case, we now know two things. A, we know that as you're looking at this fuse, the left side of it is connected to the battery and the right side is connected to the accessory. So that's going to help us install the fuse tap. The other thing that we now know is that this circuit right here, it's a battery circuit in the sense that it's on all the time. There is voltage here. It's connected to the battery all the time. The car is off, right? Okay, so that's two things. So we learned this is a fuse we can use if we want the accessory on all the time. Let's go ahead and now pull this guy out. Okay, I'll go ahead and reinstall the original fuse just so we don't get ourselves confused. Okay, and now let's go to another one. Let me look at my little diagram here. Let's go with number 2. So 2 here is the, as we discussed, it's the washer wiper pump. So it's again, it's supposed to be shooting the pump for the windshield wiper fluid. And again, this is one of these things that I think it should be an accessory circuit. For example, we come over here and look at this. If I try to actuate the pump right now, you can see, yeah, it's definitely not working. So I think this circuit is dead right now, but again, just to make sure, let's double check this. So this is circuit number 2. Here it is. Let's pull this guy out. And then let's go ahead, put in our fuse there. Okay, and now let's go ahead and check both sides of this circuit. So the left side, yep, no voltage. The right side has no voltage. So yeah, this circuit right now is not on. So I believe this is an accessory circuit. And again, to double check and verify that, let's turn the car on and see if this changes. So I'm gonna go ahead and start the car up. Okay, so the car's booting up. I think it's booted up. So now let's go ahead and do the same thing. Let's come over here and left side of the circuit. Aha, look at that. Now we got voltage and the right side of the circuit is off. So again, I think what we've seen here is that, yes, this circuit in particular is a circuit that only turns on when the car is on. So it's one of these accessory circuits. So this is perfect. We've identified 2 candidates. We have one circuit that's on all the time, and then this circuit, which is only on when the car is on. So we can use that now to hook up our, in fact, 2 separate fuse taps, so we can power our accessory in 2 different ways. The dash cam that I'm installing has 2 modes of operation. In the first mode, the camera is supposed to turn on when you start up the car and then record only while you're driving. In this case, we want to power this off an accessory circuit that only has power when the car is on. In the second mode, the camera can record video or pictures when the car is parked. So in this case, we want to power this off the battery circuit, which has power all the time. So what this means is we actually need 2 fuse taps. So as you can see here, connecting these 2 fuse taps is pretty simple. As we discussed previously, just install the original fuse and the new fuse like we showed earlier, and then just run the appropriate cable from the dash cam to the appropriate fuse tap, and then crimp it down to secure the connection. All right, so here we are in the fuse box, and let's get these guys installed. So first, let's get the accessory circuit in. So again, we want to make sure that this blade is attached to the side that is connected to the battery. So for this particular circuit, remember we tested this earlier, that was the left side of the circuit. So we again want to make sure that this part that is opposite of the pigtail, right, is connected to the battery. So I think we're gonna have to install it in this orientation. So again, it's just kind of a wiggle it in there and then just insert. There we go. Cool. We got one of these in. Now for the battery connection. Okay, this is the one that's on all the time. Originally, I think we were going to use this slot, and that might have been what we were looking at in the previous video, but actually, again, given the orientation that this has to go in, I discovered that I can't actually get it into this slot because of this metal bulkhead. So I had to change plans, and we're going to now use the slot next to it, okay? So again, it's just the same, but all we have to do again is we have to determine which side of these is the battery connection, and in this case, we discovered it's the one on the left side of the circuit. So again, same thing, we want to put the side of the spade that is opposite of the pigtail connected to the battery, so we'll go in like that. There we are. Okay, so now we have both fuse taps in. And then lastly, we've got our grounding wire, which as we saw earlier, this screw is grounded. So let's just go ahead and back that screw out a little bit. And then we will attach this guy to the grounding screw like such, and then tighten them down. And there we have it. There you go. So I think we've got the accessory plugged into the tap. So in short, that's how to install it. Let's go ahead and I will clean up these wires and let's install the accessory and just double check to make sure that this fuse tap is working correctly. All right, so I've got the fuse panel all buttoned up and I've got the cable now coming out. So again, this is the cable that's powered by the fuse taps, and it's all going up here to the dash cam that you can see. I've got it plugged in. So I guess now is the moment of truth. Let's see if this thing works. So let's go ahead and we'll start the, turn the ignition on, and we'll see if the dash cam comes alive. So on, let's come up here. And yep, the red light, that's promising. And I think if we give this a second, it should flip on. There we are. Yep. And success. So check it out. It is working. Yep, it's recording good. So it looks like this accessory is now successfully getting power from the system. And again, maybe what we should do is let's make sure that the original fuse works. So remember, the original fuse I think was the windshield wiper pump. So let me let's turn this. Aha, look at that. See, we get water. And let's make sure the other one, I think that was, maybe, did I switch it? I think it was like the heated steering. Yep, that one, or maybe it was the heated seats, but let's go check. Yep, that works. That works. Let's check the rear heated seat. Yep, everything works. Great. So it looks like this is all working. All the original circuits are still powered. In addition, we've got our new accessory circuit. So there you have it. I hope that was helpful. So a quick video on how to install and use a fuse tap to basically pull off power from your existing fuse box and power an accessory circuit. So, hope that was helpful. I think this is probably a good spot to leave it. I hope the video was enjoyable, and I hope you'll consider also subscribing to the channel. Surprisingly, if you do that, it really helps me continue making these videos. Remember, the new videos come out every Monday, so I hope I'll be able to catch you at a future discussion and we can all learn something new together. So, until then, I think I'll sign off. Talk to you later. Bye.